All right. How's everyone doing? Thanks for making time to come out and listen to these talks, even though it's like our first beautiful Monday in Seattle. Thankfully that rain is gone, the clouds are gone, and we're going to be talking about immutable infrastructure today. So before we start, has anyone familiar with immutable infrastructure? Anyone use immutable infrastructure in their organizations today? Got some guys back there. Yes, anyone not Glympse? That's good. So we've got a lot to learn today. So for our agenda, briefly we're going to be talking about obviously what is immutable infrastructure. Why do we want to use immutable infrastructure? What are the properties that it gives us? Why is it beneficial for organizations to use immutable infrastructure? And I'll go over a little bit of how you guys can implement immutable infrastructure. Now this process is not obviously ingrained. It's not. There's many different ways to actually implement it, and you'll see about that here in a little bit. One question to keep in mind during this presentation is what we have right here in terms of management. What is the difference between infrastructure and software? Okay. So a little bit about myself. As Terry mentioned, my name is DJ Enriquez. I'm the DevOps lead for the startup Glympse here in Seattle. And Glympse is the world's leading location sharing platform. So the best way to describe us, if you're meeting with a group of friends and you're wondering where people are, Glympse is that app that you can request from people or send to other people, and they'll actually show you real-time location where they're at and their ETA and basically their path, and so you guys can coordinate a little bit better with meetups. You guys can follow me on LinkedIn /DJ Enriquez. My Twitter handle is @D Enriquez Jr. and obviously at GitHub @DJ Enriquez. Okay, so immutability, what is it? So for the guys on my team and at Glympse, they know it as a buzzword, and they probably hate the buzzword, because with a lot of problems that we have with infrastructure, the first question I typically ask, well, is this thing running in immutable infrastructure? And I get a lot of my head turns, a lot of people kind of just giving me a blank eye, but it's actually a very important thing. And so the first thing about it is it's a buzzword. And you guys will probably find it in your popular buzzword bingo, right in the middle. And we'll talk about that here in a little bit. So Google defines immutable as unchanging over time or unable to be changed, right? Immutable, obviously pronounced with a D apparently. But you can think of immutable as something that just doesn't change. So think of like photos or an image, right? So a photo, unless you're living like in Harry Potter's world, your photos probably aren't going to be changing. In terms of our space, think AMIs for AWS, think Docker images, okay? Even though there's state there that will change once things are running, the basis that it comes from is always very consistent and never changes. And so what I was talking about earlier, a very important thing about immutable infrastructure, it does not mean immutable state. Okay, so we get this confused with a lot with people who are trying to run immutable infrastructure, where they have an AMI and they launch it, and then like a script runs, right? People say, oh, that's not immutable infrastructure. Well, that's fine. It's okay for things to change. There are a few properties of immutability that allow for immutable infrastructure to exist. So first important thing to remember is immutable infrastructure does not mean immutable state. Some popular definitions that you can just find from Google. And I'm going to break two slide rules here. One of them is putting a lot of words on the deck, and the second one is reading from it, but just bear with me. So Josh Stella from O'Reilly defines immutable infrastructure, something that you create and operate infrastructure using the programming concept of immutability. Once you instantiate something, you never change it. Instead, you replace it with another instance. Okay, so a really important concept that Josh mentions here is actually the programming concept, right? So going back to that question I asked you guys earlier about software infrastructure, this is closing the gap a little bit on the difference between the two in terms of management at least. So right here, just with infrastructure, we're already using a programming concept, immutability. Looking at another one, this one's from Flory and Motley, Gun.io. Automate the setup and deployment for every part and every layer of your infrastructure. Never change any part of your system once it's deployed. If you need to change it, deploy a new system. Okay? And the key emphasis for Florian's definition is actually automation, right? And so one of the things about immutability is you want to separate, or you want to disconnect the workstation from the infrastructure that you're running. And so automation is a huge part, and it's also probably the barrier of entry for immutability, is because there's a lot of upfront investment in making your infrastructure immutable, to the point where it can automate and provision itself. Has anyone seen this slide before? So this is a pretty popular slide, actually, that John Willis, he's a very famous DevOps enthusiast. I think he works for Docker right now. And these are basically, in terms of infrastructure management, it will fall into one of these three categories. The ones that history has always used, or has used for the majority of time, is divergence. Okay, this is the idea that you buy a server, you get a rack, you have some sysadmin go in there, install an operating system, install all the software. And the idea is what you had in the beginning just changes over time. Okay? And every time there's a patch, there's an update, there's a new application you need to run, that system continually changes. And inherently, because of the lifetime of that server, there's going to be a lot of drift with your infrastructure as well. And so what your server is versus what you want it to be isn't really as clear as what you want. Okay? And the industry tried to solve that, or did solve that a decade ago, almost a decade ago now, with the introduction of configuration management tools. So Puppet, Chef, Ansible, Salt. Anyone use any of those? Okay, yep. So the idea with these config management tools is, as your servers drift, you have this desired state that an automated system will basically just converge back into, right? And so this will get rid of all that drift and make sure that the servers that you're running in production have exactly what you need and are running exactly what you want it to. With the advent of cloud computing and the fact now that we can just launch instances and get rid of them and terminate things, congruence became an option. And this is really where immutability falls into place, right? And the idea with congruence is that your infrastructure never changes. And remember what I said earlier, it doesn't mean immutable state. You can change your infrastructure, but what you actually wanted it to become doesn't change from that definition. Okay, and that'll be, I know it sounds a little confusing, but I'll clarify that here in a second. And so, properties of immutability. The first one is predictability. Okay, so these are first of all, the big three properties of immutable infrastructure. So your infrastructure, whatever your provision, you have to know exactly what it's going to become, right? It has to be predictable. And that's inherently what you have when you have an AMI or a Docker image. When you run it, it's exactly what it was that you defined and saved into that state. The second is consistency, okay? And so this is the difference with immutable state. Just because you run things on the server, right, like a script of some sort, that alter the image or the AMI, as long as it ends up in a very consistent state, then you have you've satisfied the property of immutability. And the last bit is hands-free automation. And we say hands-free, not just automation, because you are disconnecting the workstation from your infrastructure on the web. So let's imagine 3 a.m. An Elasticsearch box goes down, right? Stateful box. Someone's going to get an alert most of the time, and someone's going to hop onto their laptop and run an Ansible playbook or a Chef cookbook to get that Elasticsearch node up and running, right? Well, if you have immutability, you won't get called, because what's going to happen is a new box is going to come into play, it's going to go into service, and no one gets woken up, right? Everything just handles itself, and you know what's going to be provisioned because of the predictability and because of the consistency of your infrastructure. Okay, so what does this really mean? I think this sums it up as best as I can. So your developer on the left is running applications and basically destroying your infrastructure, right? And boxes are dying left and right. But you, as the very suave and cool DevOps, SRE, or operations person, you're okay with this. Because what's going to happen is as that box dies, a new one's going to come up and replace it. That's going to be exactly what you wanted, and it's going to serve the purpose that the other box that's now destroyed is no longer serving. So, and take this with a grain of salt. Immutability, one way to see it is it's a solution to all your infrastructure problems, is to simply just kill the box. Okay? Yes, there are some caveats here. So you have an application that has some kind of memory leak, and so even though you have a new box that comes up, it's going to run into the same problem. So like I said, take this with a grain of salt, but a lot of issues that do happen, especially in the cloud, I think just this past week I've gotten like 5 maintenance emails from AWS, which is pretty unheard of, which means like the box is going to die, or they're going to restart it, or something is going to be interrupted in our service, right? We don't have to worry about that if we have immutable infrastructure, because all we do is just kill the box. A new one comes into play, and we don't have to worry about that maintenance period whatsoever. So, kill the box. And guys on my team, they hear this all the time. Whenever people are having issues, I just, we use Slack, and so I put like the gun emoji in the box. Just kill the box. Okay. This was a big concept I was talking about earlier. Remove the workstation from active management. Like I said, the big deal about this is for the people who are on your operations team that wake up in the middle of the night because of some issue that that isn't related to your guys' stack whatsoever. Say something happened in AWS. If you were to put in immutable infrastructure and you were to have some sort of automation in place that says, hey, this box is unhealthy for whatever reason, let me just kill it, that's fine, because the new box is going to come up and provision itself just fine and be in service. So again, this removes the workstation from any type of active management at all hours. So some side effects of having immutable infrastructure, obviously it tests your software resiliency, right? So you heard me talking about killing boxes left and right. One of the big things about this is the software that's running on the box obviously has to be fault tolerant. It has to be highly available. And so in order to have immutable infrastructure, your software, the stack that you're running, needs to be able to handle these type of failures. So that might mean some work on your development side. But I think that's a good thing, right? Because you don't want to run anything in production that one box fails is going to cause your company to maybe lose millions of dollars if it's down for a few minutes. And so it tests your software resiliency, and it also tests your cloudability. So you guys ever been into a meeting and someone says, oh, how did Beta B do today and Charlie C and Alpha A? Right? Like they have names for servers, which I think is absolutely crazy. Like you don't want names for servers, you don't want pets. You just want certain types. This is the application box, and we have 100 of them. And I don't care about any single one of them because they all work the same way. So if you can't run immutable infrastructure because you have this box that the guy 10 years ago created and is the core piece of your organization, you should probably solve that problem first. Okay, one thing I forgot to do, and we're going to do this right now, as part of the demo. I'm actually, where did I go? Yep, I am going to log into my AWS account, and I'm going to spin up some boxes. Since it takes a few minutes, I figured I'd do that right now instead of waiting for it later on. Just give me 1 second. Oh, looks like we're already on. Oh, that's my Glympse account. You don't want to see that. Okay. All right, so party trick. I'm not going to run any scripts. All I'm going to do is just spin up some boxes. So we have a full image here. We're just going to add one. That guy. We're going to add one to that guy here. And one to this. Okay, let's go back to this guy. All right, so key point for that slide, successful immutability depends on high availability, fault tolerance. Okay, if you have things that if you kill a box, your service is going to go down, probably you want to solve that problem first before trying or attempting immutable infrastructure. Okay, so obviously with stateless services, anyone here run ECS by any chance? Okay, so a few people. Docker? Okay, so obviously with stateless services, like running Docker services or whatnot, it's very easy to just kill a box because as a new service comes up, think of kind of like restarting your computer, it's just going to work again. But what about stateful services, right? What if you have MongoDB, Elasticsearch, MySQL, right? What about those instances? You can't just kill them because you're going to lose state, right? Well, fortunately, in today's world with modern technology, a lot of these solutions actually have ways you can configure them to be highly available. So again, going back to testing your infrastructure, your architecture, this kind of forces your infrastructure to be fault tolerant. So with all these databases, say it's something like Kafka or Elasticsearch, which are stateful, right? There's configuration that you can set up that you can lose a box, you can lose 2 boxes maybe, depending on the size of your cluster, and not lose not have any downtime. And then there are some stateful services that just inherently are highly available. Things like Zookeeper and Consul, which are 2 service discovery systems. So really, at the end of the day, if you're using modern technology, you're probably okay. You might have to update some configuration and get it up and going, but you will be eligible to run immutable infrastructure with that. Okay, so key point, immutability promotes resilient architecture, like I said. So can't run immutable infrastructure if things are going to die just by one box going down. Okay, so fix this problem first, and you'll get to the green field. So. Okay, so those are some reasons why you want to use immutable infrastructure. Obviously reduces the headaches for people who are operating or managing your infrastructure. How to do it? So first of all, there's 2 dimensions to immutability when you're creating an instance to provision, right? There's the full image approach, and then there's a full remote approach. And the difference between these 2 is the full image approach is everything that you need for your box is already imaged into your AMI, to speak in AWS terms. You don't need anything else. You don't need to download anything else. The box spins up, and you just have to run a run command to get that service up and running. And then there's a remote option, which is your box doesn't have anything. Okay, the box comes up. Probably a script will run where it's going to download everything it needs, and then it runs. The difference between these 2, obviously, is with an image, it's much faster, right? Everything is already on the box. It's more consistent. You don't have to worry about drift. Someone might say this is version 1.0, but then actually change that later on, right, and tag it the same thing, which has happened before. So you're more consistent, and your image is faster. But you lose flexibility. Okay, so if you want to change anything with your infrastructure, you have to create a new AMI, which can take a little bit more time. If it's fully remote, just defined with a script, all you got to do is just change the variables for that script, and then you're up and going. Okay, so there's a balance between these 2. And what I was spinning up earlier is actually what we'll see. So if I go back to AWS here, and hopefully these boxes have come up. All right, here's a full image, T2 Nano, and I'm going to use this opportunity. Anyone here use Vault? HashiCorp's Vault for secrets management? Okay. A few people. So this is a UI that I wrote, and I figured it would be a good opportunity to show this as well. But basically, we have a box, and if you remember, all I did was just change it from 0 to 1, and we have a service that's up and running. So that, in its purest form, is immutable infrastructure. So it's a fully working service. You can go in here and click around. Everything is working just fine. No hidden tricks here. No one's back there SSHing into the box and installing stuff.
this is working. What we're going to look at this box is how long it took to actually provision. So this is more difficult than I thought. Throw this terminal window over here. Yep. Let me source out. Actually, let me do that. Just paste this guy in. I'm going to increase this for you guys. Okay. And look at the log. Log. Cloud. Okay. So this is, I think this is the full image. Yeah, full image. So this guy took, from the moment AWS realized that it needed a new box, 149 seconds, so a little under 3 minutes of provision. Okay, to be fully up and running. If we go to the opposite spectrum, which is the box that had absolutely nothing on it, I'm going to put this down so I can type faster. Okay, so about 100 seconds difference between these two. So 200, so another minute and a half, right? And so you can see the benefits of going full image. And then if we were to look at the scratch, which I think you guys get the idea, you're going to get a number that's in between those two, probably around 200 seconds. And if we look at this box, just to prove that it actually works, we're going to get this guy's public IP, go to port 8000, and there it is, up and running just by launching an instance. Okay. All right. So that was a full image, full remote. You saw that. Balance, I think you guys get the idea. Like I said, it's going to be a number between 250 and 150. And those are your simplest forms of immutability. And the way those actually ran, it's in EC2's user data. So anyone here familiar with user data or use it? Yep. So user data is a module that's run by Upstart, or depending on your Linux distribution, that executes as the instance provisions. So if we were to look at this one, which is I think the full remote, what happens is this thing is downloading Ubuntu, or downloading Docker, installing Docker Compose, downloading some dependencies for what we need for Vault UI, and then basically running Vault UI. Okay, so simplest form, that's all it is. That's immutability right there. Now you can get a lot more complicated than that, but also introduce a lot more flexibility, which is what I'm going to show you guys next. How are we doing on time, by the way, Terry? Okay. So first of all, here's another good part about immutable infrastructure. If executed correctly, you can actually even version your infrastructure, right? So have version 2.0, it goes out into production, things just start breaking immediately, right? Something's wrong. Well, you can go back to however it is that you configured your infrastructure, roll it back to the previous version, maybe it's 1.1.2 or something like that, and then kill the boxes, the new ones, and boxes will come up again that are provisioned with the old version. So if executed correctly, your infrastructure can be versioned, you have consistency, you can roll back, and you have this version lock. Okay? So I usually like to name these things. I couldn't think of a clever enough name to talk about this, so I'm just going to call it DJ's method. So in terms of immutable infrastructure, the way I would do it is, one, you want to codify your infrastructure. And this is not Chef or Ansible or Puppet. This is your basic form of just bash scripts. Okay? Things that will just run on any Linux distribution from scratch. Use GitHub, right? You want to have some kind of version control system to be able to version your infrastructure.
use CI/CD. So with every commit that you make to your repository, it's going to automatically deliver itself and be ready for deployment. Cache the common resources and dependencies. So this has to do with the image and remote that we were talking about earlier, and how to set up if you want like full remote for full image. So what you want to do instead is cache all the common artifacts that most servers will need. That way, all that you have to download when the new boxes come up are just the diffs, right? So if you're running Docker, really cool thing to do is ask your organization, hey, what are all of your base images? Okay, because most of the applications that people run, they're just going to be diffs on top of that gigantic base image, which usually is the biggest part of the Docker image. And the last part is obviously you want to version your production infrastructure. Okay, so here's how a development DevOps engineer or SRE would actually make changes to this. You have the engineer, you have your version control system, you have CI/CD, which in this case we're using shippable, and then you have the destination or the source, which is going to be AWS S3. So this is very similar to your typical software development. What's the difference? Can anyone point it out? The Batman or the unicorn, guys. That's the difference, right? So, so in the DevOps world, everyone talks about the DevOps unicorn. Well, we are the people that is conquering that unicorn. Okay, that's what we're doing here. So I have a public repo that you guys can look at if you want to. GitHub.com. I can find my mouse. I should probably just mirror this. Oop, that's not going to find anything. This one. So not that far. So GitHub.com DJ Enriquez Immutable Infrastructure. This is a public repo you guys can look at, which is what is provisioning these instances. And there's two big parts to this. And this might get a little technical, so bear with me. But you see a lot of supporting folders here. The two big ones are just tenant and type. Okay? And what that means is in this repo, we are defining every single type of server that we want to run in our organization. Okay? We have the application server, we have the Consul servers, and we have, say, the front-end servers. Okay? Every change we make to the infrastructure regarding these types will be done and version controlled, and can have release tags put on them so you can version them, and your infrastructure will spin off of what is sourced from this repo. And the way we do that, if we go back to our slides here, is as you make commits to GitHub, okay, your shippable CI/CD will actually grab the diffs and is going to push them into S3. So what we have, I was actually pretty surprised about this, but no one apparently took the immutable infrastructure bucket, so I got that one. And so I decided to also look into immutability. No one had that one either, so I have both of those now. So in the immutable infrastructure bucket, here you are going to see a representation of that repo, where we have different versions here, 1.0, 2.0, and dev. Dev represents the master branch, right? So as you're making feature branches and you're merging them into master, dev gets updated because that's where your development environment hopefully is going to be running it. And then if you want something to run in production, you're going to reference one of the version branches here. And so with every commit that we make to master, it goes into dev. If I create a release tag in GitHub, that's going to publish one of these version tags. Now, how does this go into our infrastructure? You might be asking. Let's just do, I will get better at this eventually. There we go. Okay, so here's the process. So ASG launches the instance, right? Kind of like what we did earlier where we change it from 0 to 1. Cloud-init executes, and cloud-init is basically going to identify what is the server based off of the tags that the server is tagged. So if it's type application, it's going to be an application server. If it's tag console, it's going to be a console server. Once it figures out what it is and what version to run, it's then going to download all of the provisioning resources that it needs to get into that desired state. Okay, so provisioning resources downloaded, and then it just executes them, it bakes them Does anyone know what that picture is on the right? Guardians of the Galaxy Volume 2. No one stayed after the credits today. So that is the Adam Warlock cocoon. Okay, and Adam Warlock, for all of the nerds out there, is the savior of the Marvel Universe. And that's what we're doing here, is we're creating the ultimate infrastructure, the ultimate server. And what is the ultimate server? It is a stormtrooper. Why is it the stormtrooper? Sorry, I don't mean to diverge from our talk here, but the stormtrooper is a good representation of this because it is consistent, right? It is powerful. I still am arguing with some of the guys on our team that it's like the most feared thing in the universe. They say not because they don't know how to aim or something like that, but yeah. So the stormtrooper is consistent. It's infinitely scalable, right? Think of the clone army, right? You can have as many of these things as one, and they're very consistent. The same thing with our infrastructure. If we do immutability correctly, we will have very consistent servers. We can scale them because they're all going to be the same. Okay, and so you have that. So let's see that. Let's put that into practice here.
Nobody minds when you kill them.
Oh, is that? Sorry.
Nobody minds when you kill them.
Yeah. Nobody minds when you kill them. Exactly. That worked out much better than I planned.
Yeah, but they often miss the target.
See, that's where it falls in this case, because hopefully these things don't miss, which is why it's the Adam Warlock cocoon. So, a few things here. I have a Consul cluster running Consul under my domain. And in here, this is where we're going to define which version of the infrastructure we're running. So Consul by HashiCorp is a service discovery, platform monitoring, key value storage. It does all this cool magic stuff. Yeah, it's getting kind of hot. Thank you. So we are going to be running under the demo tenant, right? And the idea of the tenants is you can have multiple tenancies for your different types of applications. The application, we're going to run version 0.20. Okay? And so in AWS, here's our demo application. We're going to change this to 1. And what the application server is, it's actually just an ECS server. So as this thing provisions, we will expect to see a box inside this demo dev. Now, unfortunately, we're not at the place yet where I can change it to 1 and everything just instantly happens. Hopefully, AWS will get it right and finally, I want a box and it's just there. But I think we're a little behind the times for that. While that's changing, we have Consul here. What's the best way to show this? Let me log into one of the Consul boxes. Okay, Docker exec dash IT. Oops. Oh, did you something? Oh, it's a people sign. That's not gonna work. Console. We're gonna enter into basically a Docker container, a Consul container. We're gonna do Consul members. So what's important here is the build number or the version. 083. Okay. And what we're going to change here, and say this is production, someone says, crap, 083 did something wrong and everything's failing. Well, I'm going to go into my configuration and say, well, for Consul, I now want you to run 010. Okay? That's been updated. I'm going to go back into here. Hopefully the demo gods are good to us today. I'm going to kill this box here. Whoa. There we go. Terminate. And we'll wait for that one to come up. In the meantime, it looks like our application server is coming into play. And there it is. We have a container instance up and running, and then we can run whatever services we want in ECS. We go in here. It is running agent version 114.1. Okay, the important part here is if we go back to our repository, and we go to application, provisioner stage,
So this can be done in whatever way you guys want. I'm just showing you guys how you can version things. This is running version 114.1. But if we go back to our releases, 010, this was actually 113.1. Okay? So what does that mean? Well, I'm going to go to application. I'm going to change this to 1010 because 14.1 is causing all my containers to just blow up. And I want to go back. I'm going to change that version to 010. And I'm going to go back to my ASG. And in this case, instead of killing it, so I can show the difference, I'm just going to add another box. Okay, so now we're going to have 2. I think that's right, yeah. In the meantime, first of all, as you can see, we kill the Consul box, right? And Consul is still running. That's because with immutable infrastructure, like we talked about earlier, it has to be highly available. And Consul is one that serves as that satisfies that requirement. And so as you can see, there's only 2 Consul servers right now. That's because the third one, hopefully AWS detected that I needed a new one. Yep. This one's coming into play now. Hopefully this is the Consul one. Actually, this is going to be the application one. So that's one thing about ASGs, which is fine. You kill a box. Sometimes it takes the ASG a few minutes to say, hey, the box is dead. I'm not in my desired state. Let me spin up another one. So while we wait for that, we can continue on with our slide deck. Okay. So to summarize the talk, okay, immutable infrastructure does not mean immutable state. You can run things on the box that are that change the AMI or the Docker image or whatever it is, as long as you establish consistency, okay, and as long as the state that it does end up in is a state you want it to be, so that predictability. And obviously the last piece is you want all of that to happen without touching anything. Okay, so that hands-free automation, those 3 properties is what will give you immutable infrastructure. If you have any issues with the infrastructure, kill the box, like the stormtroopers, right? No one cares about it. New one's going to come up, and the army's still going to be there. This removes the workstation from active management, right? Think about what that means for all your ops guys. They don't have to wake up in the middle of the night because of some weird issue. And if they do, you just have to kill the box, right? So it's much simpler to handle your infrastructure. Successful immutability, one of the main requirements, depends on highly available services, so fault-tolerant services. If Consul was not highly available, when I kill that box, everything would just die, right? And so we cannot have immutability in that case. And a cool side effect to immutability is it promotes resilient architecture, right? So obviously, in order to be successful at immutability, that kind of speaks for how good your architecture is. If you can't do immutability, you probably just have some work that you have to do to be able to get to that point. But this is the dream, right? Where your infrastructure just takes care of itself, self-healing. And so you might think, so where do I start, right? So when I joined Glympse, I actually moved really fast. I think I changed everything right away. I didn't really have many friends at that time. That's okay, because we're in a good place now, I think, Sloan, right? I think we're in a good place now. What I would advise you guys to do is one technology at a time. What do you guys have an Elasticsearch cluster? Do you have a Kafka cluster? Do you have a Consul cluster? Do you have an ECS cluster? Right? Look at that, figure out how to automate it so that you don't have to touch it anymore, and make that immutable. Once you get that pattern going, move forward to the next server. So start small. Stateless servers, obviously are much easier. You don't want to try this on your production database and just make that go kaput. That would not be a good thing. Let's look at the state of our servers now. So if I go back to ECS, we now have 2 instances. Okay? The difference between these is one of them is running 113.1. So just by changing that one value in Consul, I've successfully rolled back infrastructure. Okay, just by that one change. Nothing more. I mean, I did change the ASG to 2, but you get the idea. And let's go back to Consul. I think we have 3 now. Yep, 3 Consul servers. What's different about this one? Well, obviously, there's one of them that's left. That's fine. The 3 that are alive, you'll see that the very bottom one is running 082. So just like the ECS cluster, we've successfully rolled back our Consul infrastructure, and one of them is running 082. That's pretty much it. So, questions? Yes, sir.
So in something like this, your data is the one thing that you have to make sure is not in this. That I can see what's talked about. So I
Yep.
imagine that that's going to be running on some other pad.
Yeah. So to answer that question, so stateful services or databases is a very difficult thing to execute immutability, but it's not impossible. Okay, so in these cases, for databases, for example, one property is replication, right? So if all of your indexes or your databases are properly replicated, you can get rid of things and not worry about data being lost. In this state, when this instance died, it did lose its data, right? That instance died, all of the volumes that were attached to it died, unless you had some kind of solution for that. But that's okay, because our services and our data is highly available. So as a new one comes up, hopefully when that new server comes up, it's going to establish replication with a cluster that it's going to join, and you lose no data in that case. Does that answer the question?
Yeah. Actually, I have 2 others.
Yeah, no, go ahead. Keep going.
I mean, it's basically reminds me of an older technology called blue-green.
Yes.
You had like 2 production environments, and then you built up one, you staged a VNet, and then you moved over to the VNet, and then you.
Yep.
So it just kind of seems like a more kind of virtualized version of it.
Yeah. So this is very similar. I mean, a lot of this actually follow the patterns of blue-green deployments, which is the idea that you have 2 working copies first, and you make sure one of them is running the way you want to, and then you swap over like DNS records or something, right? So that all your traffic goes to that green deployment from your blue deployment. Yeah, this is very similar. The difference in immutable infrastructure, I don't know if it's really a difference, more of a complement, is it takes into account the fact that infrastructure is disposable, okay? That we can throw things away and not have to worry about it. So in a way, it sort of takes advantage over that principle of blue-green deployments. And it basically just carries into its new paradigm, which is another way to manage infrastructure. Instead of deployments, we're just actively blue-greening at this point.
But last question.
Yeah, sure.
This is to go back to configuration management. Using immutable infrastructure and stuff like you don't have to use configuration management tools
That's correct.
like Chef. or
Yes.
something. So it'll save you money like that in license.
Yeah, so that saves you money, and those configuration management tools are obviously very good tools, and they can complement immutable infrastructure in many ways. For example, we still use Ansible today, right? And so if you have some security patch that's huge, say the next Heartbleed, right? You don't want to kill all of your boxes just to put the Heartbleed patch in, right? And so that's where Ansible will come into play. We can use the Ansible ad hoc commands, run the patch against all of our servers. So just like anything else with management, this isn't the one-all solution for everything, but it sure as hell makes everyone's life a lot easier for most of it. Yes, sir.
When you speak about caching, is that
Yes.
image caching?
Yeah, sorry.
Yeah.
What I mean by caching is that you don't have to download anything, right? Everything will exist on the image already, so yes, it is image caching.
When you're downloading the image to start up, it's not like you're keeping images just in memory running, waiting for things to download.
Right. So it's going to be in AWS, for AMIs, for example, for the most part, when you're launching an instance, no matter what kind of AMI you have, your instance typically will come up at the same speed. So if your AMI has all of the resources that you need to get the server to the state which is what you want, you save all that time in downloading. So you cache all your resources, or I don't know if that's, probably imaging is probably the better word
No,
to
it's
use.
image
Yeah. So you're imaging everything into
So
to
then
the
I have
image.
a follow-up to your experience.
Yes.
When does that image caching become too big?
Yeah, so picture this. You have 100 Docker images in your organization. And you're like, I want to image everything. And next thing, your boxes don't even provision. Why? Because your volume is like 200 gigs large.
So what's your
Right.
real life experience with
So the experience for that is the advice I gave of finding that balance depends on how your organization is set up or what kind of stack you guys have. If you're running Docker, which is what I can give you advice on from my experience, look for base images. Okay, those are the biggest layers typically for a Docker image, because most work that's done on a Docker image, you're just diffs on top of that base image. So if you can, image cache out all of the base images, you save yourself a lot of download time. When a Docker pool is happening, there's still diffs being downloaded, but it's not the big layer.
Do you have any kind of rules about what goes in the base image and what doesn't?
Well, so typically I use public base images. Docker, the registry 2.6 or 2.0, I think 2.5, made their imaging a lot more efficient, where they're actually going to do checksum or hash checksum matches instead of like looking at a specific tag. So even though things were built on different machines, if everything is the same, it still uses that same image. So what that means is, even though you have 50 different servers building the same Python 3 base image, right? The Docker registry or the Docker engine will still see that they're the same base image. And so what that means is, even the base images in your organization, they're coming from some other base image, right? Some public base image somewhere else. That's what you want to cache into your
Really is the
environment.
lowest common.
Lowest common denominator, yes. Yes, sir.
So I have a two question,
Yes.
maybe a little bit basic or technical.
That's fine.
So first one is, as far as I see, it's very AWS dependent.
Yes.
So how much effort and what part of this scripts you
Yeah.
spend your effort into if you want to move into like Google Cloud or,
Yeah, so
or Azure?
actually tried a small startup with some friends, right? And everyone's running AWS these days. And we're like, yeah, we're going to try GCP. And so we did establish Immutability GCP. At the end of the day, what you really need, okay, going back to the slide here, I know you guys love the Batman unicorn there, but don't worry too much about what's implemented here. Worry about the category, okay? So version control system, you can use GitHub, but use GitLabs if you want to, like team member 1, right? Yeah. CI/CD, shippable, Jenkins, Travis CI, Circle CI, all of that works. For your source, S3, Google Storage, I forget what they call it. Sorry?
Google Cloud Storage.
Google Cloud Storage, yeah, sorry. Or Azure's blob storage, right? So all of that stuff, it's all serves the same purpose. All you need is some place to store all these definitions that you can download. And so with AWS, if you're running AWS, it makes it very easy to use S3 because you can take advantage over IAM roles and policies. Same thing with Google Cloud, right? You can use their whatever they call it, protection system or security system for making sure that you're authenticated and allowed to download those resources. But it doesn't matter what cloud you're running in, as long as you can fill these gaps. Now, honestly, the most difficult part here is probably finding a unicorn, right? So, yeah. Second question. Do you have did I answer your question?
Second question is, so if you want to create immutable infrastructure
Yep.
in your private environment,
Yes.
you need something like Kubernetes or Mesos or something like that for these to be able to run.
Not necessarily. So it does help a lot when you have some sort of tool that's orchestrating all your services, right? So ECS or Kubernetes or Mesos, but they're not necessary, right? The Consul servers that we ran up, which were also immutable, do not run under any of that. That is just a base Docker on Ubuntu that's running a Docker run command. In fact, like I said, so this repo is public, so you guys can take a look at it. But if we were to look at how Consul actually runs on this thing, type Consul provision. So to walk through this, the user data is going to, actually that's actually a cool thing I should have shown you guys. So I'm going to diverge a little bit, but I promise I'll answer your question here in a second.
I'm just wondering, there must be some kind of service that monitors all these like machines
Yeah.
and hey, this guy is dead. now
Yes.
we need to trigger this. Then.
So immutable infrastructure doesn't actually answer that problem, right? And so in terms of monitoring, making sure things are running, the one component is the ASG. That's it. So you have automation in place that however you define a server to be unhealthy, all it's going to do is just kill itself, right? And the ASG says, hey, I'm missing a server. Let me throw another one back in there. That's all it is. But a cool thing to show you guys, if we look at the user data for these boxes, what this guy is doing, all it's doing is this first part here, it's just identifying itself. What am I? You know, what's my region? What's my instance ID? What's my IPv4? What type of instance am I? So this is using AWS tagging, and is basically figuring out what was I tagged for the type field. What's my tenant? Who do I belong to? What's my environment? Am I running dev? Am I running prod? And then based off of these things, actually one more thing, then it figures out which version to run, right? And the reason why we're using Consul is Consul has a RESTful API, which makes it very simple to query its config. So what version am I running? Those combination gets put into this S3 download, where it's going to download from this immutable infrastructure bucket the version that I found for my config, the type of server that I found, okay, and it's going to then just run that provision file. That's it. In the provision file, again, more identification. You know, specific to Consul at this time. What Consul version to run? Is there any additional scripts I need to run? And then it just runs Docker Compose up. Docker Compose up is going to run this file, where all it's running is just the Consul container. That's it. And so this is a more obviously evolved solution. If you remember our earlier solution of just the base user data for Vault UI, just one big script and user data. It can start there. That's simple. And then it can evolve into these things as you add tenancy, as you add versioning, as you add different ways of diversifying your infrastructure. Yes, sir.
I think it's only going to repeat now, but has had success on Windows servers.
What's that?
Windows servers.
Yes.
And how easy to like domain join?
That is a question that I unfortunately cannot answer for you. I do not have experience.
You can do
with
that. When I worked with DJ back at InfoSpace, we had pretty much immutable infrastructure with all Windows stuff. So you can script that just as easily using the active domain construction tools. We use heavily AMIs. I think the
AMIs.
AMIs, yeah, the boot up time now on Windows, I think AWS has it down to 7 minutes. But you pre-bake most of that stuff. We were a big IIS shop, so we do a domain join, and you have the ability to use domain join.
Yeah, so if anything, this is a practice, right? And with any type of practice, it's agnostic to all these different fields. So hopefully Windows is able to run script. I think it can run script, so it can probably do this. Anybody else? Questions? Go ahead.
The image versus remote, which one
Yes.
do you favor and which one do you
A balanced approach, for sure. The remote, it's too much flux going on there. So one of the problems is, I don't know if you've noticed, but a lot of times in the weekend, like in the middle of the night, a lot of repos will be down. So if you try to run things with like npm install or apt-get updates, they tend to fail. I think that's when they're updating their mirrors. So if you have everything full remote, you're pretty much screwed in that case. So you want to image some things out, right? But keep that good balance, right? And so what we're doing here for this case, for this implementation, is Docker is already installed. Docker Compose is already installed. The Docker image is already on the box, right? So all it's doing is it's just saying, okay, out of all these resources that this image has, which ones do you want to use? And then use them. Yes?
This is kind of two questions related. First is, how do you deal with patching? And the second is, any data security considerations?
Yeah, so with patching, it depends on how immediate or important that patch is. If it's very important, like a patch for a security vulnerability, right, and it has to go to all infrastructure at the same time, that's where we use Ansible, right? So immutable infrastructure, we can do that, but it's a slower rollout because we have to replace one server at a time, or however many servers the cluster can
can lose without having any downtime. And so in that case, we would actually use Ansible still and run an Ansible ad hoc command against all of the infrastructure to update them just at that point. But we will also update our configuration so that any new boxes will already have the patch applied to them. So, and the second one was, second question?
Oh, just data security considerations.
Yeah, so,
Very general question.
yeah, so we leverage, obviously AWS security. We trust the security that AWS gives us. S3 never goes down.
Depends on the question.
Yeah, sorry, I had to pause there for a second because I know people would catch on to that. So we use S3 obviously, and we trust their security. They have a very good white paper on security. We use their IAM policies and principles to make sure that who has access to these resources is just us. And obviously for GitHub, keep your private repo, or if you are very generous, you can make it public, like this repo is right here, and share it with the world. So in terms of security, all the rules still apply, and they can be applied to this practice as well.
Right.
Questions?